In this section, we're going to be discussing some of the characteristics of rational functions. First of all, you're going to be asked to determine the domain, and as you're familiar with, domain is your x values. But as it states here, specifically for the rational function, this is the set of all real numbers except the x values that make your denominator equal 0. Of course, as we know, we can't have 0 in our denominator. Therefore, those particular values would not be included as part of your domain. Okay, so looking at a couple of examples with finding domain. Okay, so our first function here, we have h of x is equal to x minus 6 divided by x squared minus 64. All right, so we need to find out what causes our denominator to equal 0. A couple different ways you could do this. X squared minus 64 will factor, so you could factor with the difference of squares, or if you choose to do so, you can use your square root property. So we can set it equal to 0, add the 64, and then take square root of both sides, which will give me plus minus 8. So those are the values that would cause this particular denominator to equal 0. So they would have to be left out of your domain. Now, taking this and writing it in interval notation, of course, as it started out, it says domain is the set of all real numbers except. So when you're thinking about the set of all real numbers, you're thinking negative infinity to positive infinity. But we do have to leave out the positive 8 and the negative 8. So with interval notation, you would start with negative infinity. And, like if you're just following your number line, say from left end to the right end, you would come across the negative 8 first. So the negative 8 is going to have to be left out. Then you would go from the negative 8 to the positive 8. But then the positive 8 would have to then also be left out. So basically there's two numbers being left out, which causes your number line like to be chopped into 3 sections. So therefore you would do like an interval notation for each of those 3 sections. Okay, next one. Had f of x is equal to x squared divided by x squared plus 5. Now, x squared plus 5, won't factor under what you're typically accustomed to dealing with. So, just like I started out a while ago, let's take this and set it equal to 0. And I'm going to subtract my 5. And then I'm going to take square root of both sides. But now, in this case, you're taking square root of a negative. Therefore, you're going to end up with an imaginary number. Now, domain, again, think about what the definition said. It referred to it as being the set of all real numbers except. So when you're discussing domain, that does not include anything that is imaginary. So in this case, since it comes out to be imaginary, you actually don't have any values that have to be left out of your domain. Therefore, you would have negative infinity to positive infinity. All right, the next characteristic that we're going to look at is going to be a vertical asymptote. Okay, so here's our definition for vertical asymptote. Vertical asymptote occurs at x values that make your denominator equal to 0, as long as that value does not also cause your numerator to equal 0. So you actually start out, in a sense, the same way that you did with domain, as far as finding these values that cause your denominator to equal 0. But once we find those, we need to check and make sure that it does not cause our numerator to equal 0, because if it does, it's actually not a vertical asymptote. It's just like a hole in the graph. Of course, you're familiar with vertical asymptotes, but just a quick reminder. Like if you do have a vertical asymptote, typically we just dot those in. But what happens as your graph approaches a vertical asymptote, whatever the function or graph may be, it's going to be forced to either turn and go up beside the asymptote, or it could be that it's forced to go down beside it, but your graph doesn't ever go across a vertical asymptote. Now, what I mean by a hole in the graph, of course, I'm not necessarily drawing rational functions here. I'm just giving you a concept of what the asymptote and what a hole is. So, I mean, even with a line, I mean, you can just have a line that has a hole. I mean, it literally what it says is just a hole in the graph. So that would just mean that that particular x value is not included. Now, you don't have to determine, you know, whether it's a hole or not. It's not like you have to state that, because we are just looking for vertical asymptotes. Okay, first example for our vertical asymptotes. You notice your instructions says to find the vertical asymptotes, if any, because your graph doesn't actually have to have a vertical asymptote. Okay, start with your denominator, and we need to find those values that cause our denominator to equal 0. Like I said, you're going to start out basically the same way you do when you're asked about domain. Now this one I'll actually have to factor. I do have a common factor of x. Okay, so once I get it factored, then I do need to set each of those factors equal to 0. Okay, so I end up with an x value of 0 and an x value of 6. But I've got to check to see what those values do to my numerator. So if I take x equals 0 and substitute it into my numerator, 2 times 0 will give me 0. So since this also causes your numerator to equal 0, this is not a vertical asymptote. Now, like I said, you're checking your answers. It's just not going to say anything about the x equals 0 because you were specifically just asked for vertical. But as I told you a while ago, really what that means is there's a hole in the graph. Okay, x equals 6. So you do 2 times 6, you get 12. So again, as long as you don't get 0 in your numerator as well, then this will be your vertical asymptote. So like when you're checking your answer, the only thing that you're going to see is just the x equal 6. Okay, one more. Okay, so this time my function is g of x is equal to x minus 6 divided by x squared x squared plus 1. Okay, so start out setting it equal to 0. Okay, subtract your 1. So then when you take square root of both sides, we're going to end up with plus or minus I. Alright, so just like domain didn't incorporate anything imaginary, that's only specifically dealing with real numbers, your vertical asymptote is the same way, because, I mean, when you go to graph rational functions, and if they have vertical asymptotes, you put that on your graph. And all that you have on your coordinate plane is just your real numbers. So because this comes out to be imaginary, this actually doesn't have any vertical asymptotes. Okay. Now, like the first example I did ended up just having one vertical asymptote. You can have 2 vertical asymptotes. You can have 3 vertical asymptotes. You know, so there's any amount of vertical asymptotes can occur.